Welcome to this concept video on the sine and cosine rule. In this video we'll cover what they are, where we can use them, and why we care about them. The rules are as follows. The sine rule looks like this, where the lowercase letters are sides and the uppercase letters are the angles opposite the corresponding sides. And the cosine rule looks like this, and we can rearrange to find the angle instead, like this. But don't worry, all three of these equations are given on your equation sheet at the start of your paper. Let's look at the sine rule in more detail. So the sine rule relates angles and sides opposite to one another, which for a pair, like this, to another pair of angles and sides. And usually when you do questions, you only relate in two pairs at a time, so you only actually need two out of the three pairs shown in the rule. So the sine rule applies when we're interested in two pairs of angle and sides. We can also rewrite these in another form, where we just flip both sides of the equation. So we write sine A over A equals sine B over B instead. And this is perfectly valid, you can always flip both sides of the equations. And we use the first one when we're looking for a side, because when the sides are on top it's easier to rearrange. And it's more convenient to use the bottom one when we're looking for an angle. You can always just use the top equation and rearrange more. It just helps the maths a little bit more if you just start off with the thing you're looking for on top of the fraction. So let's look at some examples. So here's an example where we can see we're looking for x, and we're given the angle opposite x, so we've got one pair, and we're given another pair as part of the initial part of the question. So that means we're looking for a side, so we'll put the lowercase letters on top because they're the sides, and we'll just substitute in what we've got. So x here is just our A, the thing we're looking for, and the angle opposite that is the capital A. And we'll call the 7b and we'll call the 50 capital B. So we'll sub it into our equation. So x is A, so it's just x over sine 35 equals 7 over sine 50. And in order to get x on its own, we can times on both sides with sine 35, which just amounts to bringing 35 up to the other side. So we get x equal to sine over sine 50, 7 over sine 50 times sine 35, and you pop that on your calculator, x comes out to be 5.2. And let's look at another example. This time we're asked to find an angle. So again, we're given the side opposite the angle, so we form one pair, and we've already begun another pair. And this time we'll write the angle on top, it's the sign of the angle on top because it's a little bit easier to work with. And we identify here that x is the capital A we're looking for, and the side opposite is just A. And we'll also label these guys just so we know what we're subbing into the equation. And we sub them in, we end up with sine x over 7 equals sine 35 over 6. And again, we rearrange to get sine x on its own, so we'll bring the 7 up to the other side by times on both sides by 7. And that leaves us with sine of x is equal to sine 35 over 6 times 7. And pop that in your calculator, we get out that sine x is equal to 0.699. And the reason I've not rounded it up to 0.7 here is because we're not done yet. We need to find just x on its own, and you don't round to the last step. So x is the inverse sine of the answer we had above, and if you pop that in your calculator, x comes out to be 42 degrees. So let's summarise the sine rule. We use a sine rule when we've given or we're trying to find two pairs of angles and sides. So one of the four components will be missing, and we can use the sine rule to find the last component. Now let's look at the cosine rule in more detail. So the cosine rule actually has three sides involved and only one angle, and we call this angle included angle because it's between two sides that we're given. And we need to note that the angle opposite the capital A is given lowercase a to show that the two of them are linked. So we use the cosine rule when we're given three sides and an angle. And we use the one on the left when we're specifically looking for the third side, which is opposite the included angle. And we use the one on the right when we're looking for any of the angles if we're given all three sides. And as long as you pick the right A, i.e. the lowercase a, opposite the angle you want, you can find any angle you want if you have all three sides. Let's look at some examples. So here you can see we're given two sides and an included angle, and we're asked to find the angle opposite. So we'll label the angle opposite the lowercase a, and that lets us use the left-hand equation. And we'll label the other two sides just B and C. Doesn't matter which way down you label them. So we're using the one on the left because we're trying to find x, which is the side opposite the included angle. So we'll sub in all our letters into our equation. So x replaces a here, 5 and 6 replace B and C, and 50 replaces the angle A. So with that all subbed in our equation, let's plug all the things on the right hand side into our calculator Notice how I put all the terms after the minus sign in a bracket just to make sure we take them all away. And that leaves us with x squared equals 22.43, but we don't want x squared, we want x, so we need to take the square root of that. So x is the square root of that, so we got. And you put that in your calculator, x will come out to be 4.7. Look at one more example. And this time we're asked to find an angle, and we're given all three sides. And this means we need to use the equation on the right, and we just need to make sure that we put the right things in the equation. So we want to identify the fact that 5 is the angle, the side that's opposite the angle we want. So then 5 we label as the A. And that's why you need to make sure you label correctly, because it has to be a side opposite the encoded angle that gets labelled as a lowercase a. So then x is just a capital A, and we just label 7 and 6 B and C. So let's plug that into our equation on the right. So we get cos of x is equal to this guy on the right here. Just plugging in 7 for B, 6 for C, and 5 for A. And put that in your calculator, we get that cos x is 5/7. And again, we don't want cos x, we want just x on its own. So you get x, you just take the inverse cos of 5/7, and you put that in your calculator, it comes out to be 44.4 degrees. So let's bring that all together. So we use the sine rule, we've got two angle and side pairs. And we use the cosine rule, we've got three sides and an encoded angle. So I've had to look at what the rules are, where they apply, and how to apply them in certain examples. If you want more practice on how to look at examples, have a look out for the following video to this one on the examples of sine and cosine rule, where we go over some past paper questions. And we'll round out today's video with why we care about them. The skill of identifying and applying the right equation or rule is relevant across all of STEM. I can mention this skill is relevant to every single day in my life as a physics student. Just knowing things isn't enough. You need to know how you can apply your knowledge to certain situations and problems. And as we mentioned in the intro video, using trigonometry and triangles is relevant across a lot of part of architecture and engineering. It's using angles and sides to get other angles and sides to directly measure them. It's always useful. And slightly more relevant and immediate to you is you'll be looking at more trig identities and rules next year, so get familiar with this type of thinking and problem solving skills will be really useful. This brings us to the end of the video. Be sure to have a look at the examples video for more practice on this.